So in section 12.2, we were looking at systems of 3x3 equations. The thing about these equations is that each one of these actually represents a plane, not just a line, but a plane in so-called 3 space. We're looking for solutions to this system of equations, and that would be where the 3 planes intersect each other. Now, in the first part of this video, I talked about the planes being the walls, the floor, and the ceiling, and a point of intersection could be like a corner point where 3 walls and ceiling or floor meet. Now, in order for something to be a solution, the planes have to intersect at that point, and if they do, that point would have coordinates of x, y, and z. So one problem that I could give you would be to test whether or not something is a solution to a system of equations, and that number or that ordered triple would have to fit in each of these equations. In other words, it'd have to make them each true. So if I gave you something like this, your job would be to plug in -2, 1, and -3 and see if it worked in each one of these. So let's start with the first one. Plugging that in, I end up with -8 plus 1 plus 6, and I don't think that's equal to -8. So do I have to keep on trying things here? No, that's it. This is not a solution. Now, actually checking all the different possible random sets of 3 numbers is probably not a very efficient way to solve a 3x3 system of equations. So we're going to have to find something a little bit more methodical, and let's do that. Let's take a look at something like this. Now, this one's a little bit harder than some of the ones that you'll see. And the reason it's harder is because a couple of these equations don't have a particular variable. They're missing. I would suggest you start this by rewriting it in a little bit more neat of a fashion. So write it as x plus, well, there's no y, so I'll leave a space there. X plus 6z equals -54. And then 5x plus 3y minus 2z equals -14. There's no x in this one, so I'll just do y plus 4z equals -30. Let's see. Let me just double check my number here on that one. Equals -32. I wrote -3z just by mistake there. I was like, wait a minute, that's not right. So that should be a -32 there. Okay, that's a little bit better looking in terms of a little bit more organized. And you can see that I'm missing, for instance, a y here and an x here. A lot of times this gets confusing for people, but it's actually made it a little bit easier for you, because the goal is to find 2 equations that just depend on 2 variables. Well, you're kind of already half there. This one just depends on y and z. This one just depends on x and z. So if you could somehow get rid of, say, the x from this equation or the y from this equation, we'd be all set. We'd have our 2 equations with 2 unknowns. So let me do it this way. Let's get rid of the x from this equation. What would I multiply the top equation by and add to this one to get rid of the 5x there? What should I multiply this by and add here to get rid of that x? -5. Thank you. So -5 times the first row added to the second row would look like this. It'd be -5x minus 30y, excuse me, minus 30z equals 270. And I'm going to add that to 5x plus 3y minus 2z equals -14. And let's... Okay. That would give me 3y minus 32z equals 256. Okay, so not so bad. But if you take a careful look at things now, I've got two equations. This one and this one that just depend on y and z. So let's solve those two equations simultaneously. So it's going to be y plus 4z equals negative 32, and 3y minus 3z equals 256. Now you can solve those any way you'd like. So one way to solve it would be the addition method, another one would be substitution. Substitution wouldn't be bad, it's just it would take a little bit longer. If you move the 4z to the other side, you could substitute that expression in here for y and then solve an equation that would result in z. But I think I see a different way to solve this one. What about you? Is there a quick way to solve this with the addition method, William?
Multiply the top row by -3.
Perfect. So -3 times row 1 added to row 2 is going to look like this. -3y minus 12z. 12z equals 96. And then 3y minus 3z equals 256. Those cancel each other out. I end up with negative. Something looks wrong here. Did I miss a sign someplace? Oh, this should be negative here still. Whew. All right. So that gives me negative 15z equals, that'd be what? 140? No. Yeah.
You sure it should be negative?
No, it is positive. Darn it. I want it to be negative. Let's see. 3y minus 3z is 256. Something seems wrong here someplace. What's going wrong? 96, because this isn't going to be divisible by negative 15. That's what's bothering me. I'm like, wait a minute, something's wrong there. The problems that you're going to get when you do these things for yourself and on an exam are going to work out with nice integer numbers, at least the ones that you have to do this way. Yeah, that's like 352. 8 times 15, 120. What's going wrong? Let's see. Y was 0. 2, 54. Negative 5 times that is 270. Oh, this is negative 32. That's the problem. That should be negative 32z. And then a negative 32z here. All right. So we can still work with William's suggestion. It's just when I add these two together, negative 3 times that should be a negative 32z. And then that's going to give me a total of negative 44z. Sorry about that. Equals 352. Ah, man, this is just a bad day. 352. Whew. So, z equals negative 8. All right, so I apologize. Let me go back because I've messed this up a little bit. Let me go back and just kind of recap a little bit. We first started out by getting rid of the x from the second equation. That left us with these two equations here in orange. 3y minus 32z equals 256, and y plus 4z equals negative 32. We're going to solve those two equations right here in any way we want. You can solve it by graphing, you can solve it by substitution, you can solve it by addition, whatever way works. From there, we're going to solve this the rest of the way by the addition method, aka the elimination method. William suggested we multiply the top equation by 3, and that gave me something that's going to cancel out that y there. It does. And when I do, I end up with z equals negative 8. So looking good there. Now, what happens from there? Well, now that we know what z is, I can go back and figure out what y is. Y plus 4 times negative 8 equals negative 32. And so interestingly enough, y equals 0. So we got two of these so far. We know what z is, and we know what y is. So the last thing then to figure out is what is x. You have your choice of all three equations. I'd pick this one because it just involves x and z. It's just a little easier. X plus 6 times negative 8 equals negative 54. So that's negative 48 here. If I add negative 40, or if I add positive 48 to both sides, I end up with x equals negative 6. Now keep in mind that when you enter your solutions into WebAssign, you have to enter them in x, y, and z form. So negative 6, 0, and 8. That's how it would look. All right. How are we looking on that first one? Okay. Let's take a look at another one. And let's see, where's that one? There we go. This one right here. Now, kind of like all these, you need to figure out, well, what equation you're going to use to figure to eliminate a variable from the other two equations. So in this case, it's up to you. What I always look for is something that has a coefficient of 1 or negative 1. Any preferences? Does any of them look easy? I mean, there's a lot of good choices. That has a coefficient of 1. All these have a coefficient of 1. And that has a coefficient of 1. So whatever one of these works for you. Any preference? All right. Well, I'm going to just pick the second equation and eliminate the x's from the other two equations. So to do that, I'm going to first multiply this equation by negative 3 and add it to this equation. So negative 3 times row 2 added to row 1 will give me negative 3x plus 6y minus 3z equals 36. To that, I'm going to add the first row, so I'll just copy that down. And end up with 10y minus 2z equals 82. And just leave that equation alone for the moment. We need to get another equation that we've eliminated the y from. So since I'm using this equation twice, I'll use this to eliminate the y down here. What am I going to multiply this by to get rid of the y here? So negative 2 times row 2 added to row 3. That's going to give me negative 2x plus 4y minus 2z equals 24. Add that to 2x plus y plus z equals 15. And I end up with 5y minus z equals 39. Let's keep going. This is what I wanted. If you notice, I've got this equation and this equation. I've got two equations that both depend on those same two variables. That's what you want to get to when you're solving these things. So you use one equation twice to eliminate a variable from the other two. When you've done that, you solve those two together any way you want. 10y minus 2z equals 82, and 5y minus z equals 39. Can anyone see a quick way to solve this one? Now that we've put these two together. What would be a good way to solve that 2 by 2 system of equations? Anyone? You could do a substitution for z. That would actually take a little bit more work than the addition method, but there's nothing wrong with substituting for z. I would do it this way. I'd move the z to the other side and get 5y minus 39 equals z, and then substitute that expression in here. Maher? Different suggestion? William?
Multiply the bottom by 2.
Yeah, if you multiply the bottom by -2, then we'll get a lot of nice cancellation real quickly. So let's do that. We'll do -2 times row 2 added to row 1. So it's going to be -10y plus 2z equals -78. And then I'll add that to 10y minus 2z equals 82. Kind of important here. What equation pops out of this? Zero equals 4? Does 0 equal 4? Did you miss that in the last class? Class before this? They taught you that? Certainly wouldn't be my class. 0 doesn't equal 4. So what's that telling you about this system of equations? No solution. Yeah, and well done, William. It's inconsistent. There's no solution. Now, if you ended up with something like 6 equals 6 here, or 12 equals 12, something that was true, then it's telling you that you've got a dependent system of equations. If you have something that's false and all the variables drop out, that's inconsistent. If you have something like, like I said, 12 equals 12, which is true, that's telling you you've got a dependent system. So kind of depends on what happens. If all the variables drop out and one of these things happen, true or false is telling you one of these two things. Now, in case you're curious, you could have solved this one by the substitution method. It just takes a little bit longer. So if you solve by the substitution method, you got to get z by itself. You plug that back in here, and then distribute the -2. Everything here cancels out, and I end up with 78 is equal to 82, but that's false. So again, that's implying no solution. All right. Looking good on those couple. I mean, that's basically the kinds of things you're going to run into in section 12.2. So if you have some more questions or something like that, let me know. If not, then good luck, and you can start working on the homework.